All right, so today we're going to use the properties in reverse. So yesterday they were written as multiple properties, and we brought them together as one single, multiple logarithms, and we brought them together as a single logarithm. Today they're going to be written as a single logarithm, and we're going to separate them out to multiple logarithms. So on the front, there were just 3 examples that we didn't do, so we're going to do those real quick. And our directions today are to expand. So on this first one, we have the natural log of 4x. And so it's 4 times x. And so if it's multiplication, what do you think we're going to use to break it apart? Addition. And 4 is going to get a logarithm, and x is going to get a logarithm, kind of like Oprah gives everybody a car. So 4 gets a logarithm, the natural log of 4, and then plus x gets a logarithm, the natural log of x. And that's it. Okay. Sometimes you have the logarithm of 2 or 3 things divided. And so we're going to separate those using subtraction. And so we have log base 5 of 5 minus log base 5 of x. Can we simplify log base 5 of 5? Do y'all remember doing that? Log base 5 of 5. You would ask yourself 5 to what power gives you 5? Yeah, that's just 1. Right. And then on the exponential property, we're going to use it like it was written. So if we have the logarithm of something raised to a power, when we're expanding, we're going to want to bring that power down in the front. All right. So if you guys have room on the back, you're going to continue these notes. If you don't, then just grab another sheet of paper. All right, so we stopped at 5, so we're going to pick up at 6, and our directions today are going to be to expand. All right, so for number 6, we have log of a fraction. Our numerator is x cubed square root of y over z to the 4th. So how many logarithms do you think we're going to have in our answer? Yes, very good. And to decide if it's a positive logarithm or negative in front of it, it just all depends on where the x, y, or z is located. So numerator means you're going to have a positive logarithm, and then denominator you're going to have a negative. All right, so we'll start off with x. So we have log of x cubed. And then since y is in the numerator, it's going to be a plus log. And then how can you write the square root of y as y to a power? 1/2. Good. And then since z is in the denominator, we're going to do minus log of z to the 4th. Great. And then we have one more thing to do, because when we're expanding, we don't want the exponents, we want the exponents in the front. So we would just take one more step, and you probably can do this all in one step on your own. But bring those exponents down. And that is your expansion. Now the next one is similar, it's just slightly weird because we're going to start off with some negative exponents, but you'll figure it out. All right, so for number 7, we have the natural log, and then we have another fraction. The numerator, we have a to the negative 7, and the denominator, we have b to the 5th, c to the negative 2nd. Okay. Now, if it was me, I would go ahead and rewrite this so you don't have negative exponents. We could do it like leaving it like it is. It just make it kind of weird because you would have like a double negative at one point. But I want you to remember these rules. So a negative exponent just means reciprocal. So if we have a to the negative 7 on the numerator, we could drop it down. Okay, so we can take the a to the negative 7 and move it down to the denominator and make it a to the positive 7. And then c to the negative 2 is in the denominator. We can bump it up to the numerator and make it c to the positive 2. So if you move something on the other side of the fraction bar, you just change the value, change the sign of the exponent. Okay, now you guys try this one on your own. Now expand it kind of like what we did on the first example. Bless you. Bless you. All right, so what questions do you guys have on that one? I've been having a lot of questions about this one.
So if they cross the bar, they swap signs.
Right.
That's all that.
Yep.
Okay.
Right. Any other questions? Okay, so let's look at another one. This one has kind of got a lot going on.
Doesn't matter which way you rotate.
So could you, do you mean you could, on the bottom, could you do b to the 5th, a to the 7th? Like switch that order? Or what do you mean?
If it was c to the negative 2 and then b to the 5th, could you rotate the other way? Or does it have to be counterclockwise like that?
Oh, it doesn't matter. You're just going up and down. I don't know what you mean about counterclockwise.
Yeah, the
You
arrow.
mean like, it doesn't matter. It's just going up and down. You're technically just going boom, boom. Okay. So for number 8, we have the natural log of big set of parentheses. Inside we have x, and then we have the cube root of a fraction, where the numerator is x squared, and the denominator is 1 plus x. All right, so we're going to do a lot of work to this before we use the properties of logarithms. So what we're going to do first is rewrite this cube root. So what exponent means the cube root? 1/3. Okay. Then, if you are going to raise a power to a power, what do you do with those powers? Multiply. Good. So that's going to be x to the 2/3. And there in the denominator, I'm just going to write that as 1 plus x in parentheses raised to the 1/3. Okay. I don't know why I'm doing. Okay. So now I'm going to multiply those together. So I went ahead and put x over 1. To multiply fractions, you multiply across the numerator and across the denominator. So when you're multiplying, what do you do with the exponents? You add. So what is 1 plus 2/3? 5/3. So if you can't do that in your head, it's okay. So your common denominator would be a 3. So you want to write 1 as so many thirds. Well, 1 is 3/3. And then when you add, that's going to be 5/3. And then multiplying across the denominator just leaves you with that 1 plus x to the 1/3. All right. So now I'm just going to use my properties of logarithms. So we have the logarithm of two things divided. So we're going to separate those using subtraction. And then don't forget that whenever you're expanding, you don't want to leave those exponents as exponents. You want to bring them down in the front. Right, and then that should be it. So sometimes it will get kind of tedious with doing addition and subtraction of fractions just in your head. All right, we're gonna have one more. So for number 9, we have log of x to the 4th y to the 6th times the 4th root of x cubed y to the 5th. All right, and again, we're going to do a bunch of just simplifying algebra rules before we start doing anything with the logarithms. Okay, so if I have the 4th root of something cubed, what would that power be? 3/4. So whatever the index is, the type of root goes in the denominator, and then the power is going to go in the numerator. All right, and then same thing for the 4th root of y to the 5th. That's going to be y to the 5/4. Okay. So then for my x's, to multiply those, I'm going to add the exponents, and then the same thing for the y's. So I'm writing out a lot that you guys probably can do in your head, and that's fine. So what is our common denominator going to be? 4. So I want to write 4 as a certain number of 4s, 16. And then I want to write 6 as a certain number of 4s, and that'd be 24. Right? Now, if you can't do that in your head, you can do it the old-fashioned way. You want to make this something over 4, so you're basically just multiplying the numerator and denominators by 4 to get that. All right, we're almost done. So this is going to be log, and then we'll add the exponents on the x's. Oh, don't forget your x. And then add the exponents on the y's. And then we're ready to use our properties finally. So these are the log of things multiplied. We'll separate using addition. And then your very last step is to bring those powers down in the front. Whew. All right. So, what questions do you guys have? Okay. So, you have less problems to do, but they are a little bit more tedious than what you had yesterday.